Hello everyone, another week. Another episode of Parallel and Concurrent Programming in Haskell. So what should we do today? Before anything, I added some chat commands. So the Discord should be there. Yep. The project that we are doing today as well. My GitHub, if you want to check that. That's not there. Yeah, so now it's there. Yes, and then the schedule. Let's see, opens here. Make sure to check it out. I need to fix this a bit better, but for now serves the purpose. And yeah, that's it. Time to start, I guess. So today it's another chapter of Parallel and Concurrent Programming. It's chapter 3, which is Parallel Strategies. Make it bigger. Yes, there we are. But first, let's do a recap of what we did on the last chapters. Just getting this ready. I think there is people ready. Yeah, I uploaded the repo. So I'm just sharing like a bunch of links. And what's there? So the lines of the book and the exercises. So last week, well, we can take a look at them in the editor. So last week we reviewed the first chapter, which was introduction, and we saw the I can't find. Hello, the beast of Middle East. That's some name, man. I like it. How are you doing? Beast of Middle East. That reminds me of this comedian that called himself the Machine and has some jokes about that. Fix and merge conflicts. I don't know if that's considered cool, but yeah, doing good. I'm just starting with the stream, so on Tuesdays I'm doing this book day. What is it? Yeah, book day, and now, well, I started with book day last week, going through this book, Parallel and Concurrent Programming in Haskell. So today is chapter 3 about like different strategies to parallelize code. But first I want to do a small recap of today. So let's find, because I draw some diagrams last week. Yes. So we first went over to the way Haskell code is evaluated and how we have these things that basically mean something that will be evaluated on the future. So let's take a look at that in HCI. So if we define x as a list of 1, 2, 3, and we check with a sprint command, it's showing this underscore, so it's not evaluated. And then we can force the evaluation of something with this sec function. The type is takes something of type A, something of type B, and returns that value of type B, any B. But in the process it evaluates A, and it evaluates to weak head normal form. So in the case of sec, yo, that's the first subscribe. Thank you so much, my man Kid Optical. And I got an emote, nice. With Prime. Thank you for the subscribe. How are you doing, Kid Optical? Yeah, so I guess I should mention that I got the last week. Yeah, I have it sitting there. I subscribed to Vlad's stream with that, but I think I should subscribe to yours now to return the favor. But yeah, I got the affiliate status, so now I can have subscriptions, and I went ahead and did the points. So now you can see that you can get Monad tutorials points. So infinite Monad tutorials, I guess I have them because I'm the channel author, but yeah, Monad tutorials is the points of this channel. Yeah, so if we do X and then we just return this unit, we don't care about that. It will be evaluate X to the weak head normal form. So if we sprint X again, didn't. That's weird. Am I missing something from previous chapter or what? A monad is something you build with monad tutorials in Twitch chat. Yeah, that's pretty accurate. In the category of Twitch emotes. Okay, so now I'm confused about this thing, and I'll have to review back the book because yeah, now we can spend the whole stream thinking about how to rephrase that with the Twitch lingo. Endo mode sounds good. Okay, so just going back to the evaluation thing, because from what I remember it should be so this is exactly what we did last week. Why is not evaluating? So if we print the whole thing, now it will be evaluated to what is wrong with... Okay, there is something wrong with the GHCI. So let's define that x again, and if we do sec, what do we get? This is not what the book shows and what we did last week, so I'm not understanding. What if we do length of x? Yeah, so clearly x was evaluated, but for some reason it's not showing. But yeah, that's what we did last week. We reviewed the evaluation and then let me see what, because now I want to, before we continue, I want to get to the bottom. So if I see to another project, then x is 1, 2, 3, or we can do even this 1 to 5. Print x, yes, but if we do stack x, okay, so let's put the type of int. Okay, so now we see that it's actually evaluated. Also evaluated the first one. I thought it was going to be something like that. But anyway, so we have like the structure there. And then if we do length of x, get that it's fully evaluated, which again is behaving. Okay, let's do the full example from the book to be sure. So what if we have map of +1 in a list that goes from 1 to 5, then yeah, and then this is a list of int. Okay, so now we get that nothing is evaluated yet. We do the length of x. Yeah, now we're getting it. So I guess with literals it's different. That's what was breaking it. So we evaluated the length, and that evaluated the whole like structure of the list. And now, well, I missed the sec to only evaluate like the first step, but now if we do like, if we print x, now it will be fully evaluated, right? And if we define it just once again, print, yeah, there we go. So in this case it's evaluated to weak head normal form. Okay, so then we saw these strategies. Yeah. So if we have the R part, which is the parallel monad, the val monad, sorry, to evaluate things in parallel or sequentially. So R par and R par, if we do it for two things, and then we can see it here, this R par and R par, that produces basically the same sorry, does this return instantly, because these two things will evaluate it in parallel when they are needed. They begin the evaluation, but it just returns instantly. Then we have rpar and rsex, where we evaluate these in parallel and these sequentially. So, and because this takes less than this one, we return once the second one, which is the one evaluated sequentially, it's evaluated. And then we can wait for both, doing like this one in parallel, this sequentially, and then we do this sequentially. And the last, yeah, that was this. So it can either way, like it will wait for both to evaluate. And then, yeah, and then there is this, which is just like rpar, rsec. It's just like more for like symmetrically. Hi Pasha, how are you doing? Yes, today we're doing Haskell. This book. So it's a specific topic, which is parallelism, concurrency, and we're just starting. So I was doing a recap of the previous chapter where we saw like how code can be evaluated in parallel, and yeah, we saw these strategies. Then we saw the Amdahl's law, so how much we can speed up a program with parallelism, and then there is a cap where you cannot get faster than that no matter how many cores you add. And I guess that's it. Yes, the other thing we saw was how to parallelize the Sudoku solver. So the first one didn't parallelize anything, example. Then the second one splits in two the array of inputs, but what we found out was that we get too many, like one of the two cores that is doing the evaluation just does much more work, and it's because if you split in two chunks and one of the chunks has more work to do than the other, then you never finish. You never finish what I'm saying. One will finish first than the other. And the third one was what we did is we define, or the book defines, a parallel map. So it's just very similar to map. If we do map here, the type of map, yes. So we go from A to B, a function that goes from A to B, and then we get a list of A's, and we return a list of B's. That's the regular map, and our map basically produces an eval of the list, which is the monad. Hey Vlad, thank you for the subscribe. Bam bam bam. Well, you're following already, but welcome to the Fellowship of the Monad. I think I'm going to stick with the name. Yeah, this is already going crazy. First day with soaps, already killing it. Thanks again. And now you can use the functor emoji. So this basically evaluates because I'm thank you. How do you apply a string over string? My title is play. Yeah. That's because it's a different language. Yeah, the trio. Who else from the group already has affiliate and emojis? So basically we define a map that evaluates each of the elements in parallel, and then that means that instead of solving like half in one core and half in the other, we will solve each one. Okay. I guess you can lose it, right? I didn't check anything about that. I don't plan to now just stop streaming, but yeah. He does his own idle stuff. Yeah, so this one turns to be quite faster because it was evaluating each of the solutions in parallel, and then there is less work that gets done in one core when the other is idle. But then we found, I closed this already, we found, yeah, the limitations. So for example, so this is the code that runs in parallel, where we solve the puzzles and evaluate them, but all of this doesn't. Yeah, and then this made sure that the list was evaluated before. So that was it. And then we saw something here. Yeah, this was actually, and I think we'll return to this, but this was the normal for data type class. It lets you evaluate things further, and there are many already types defined for it, instances defined for it. We can check that. Yes, so that was the default. Am I using? Yes, I'm using. Let's check. Haskell Green. I think this is for syntax highlight only. Yes. And then this is for formatting, and then what else? I think that's it, like from plugins, but I also have the Haskell language server, which is quite new. And that integrates with Hawkbeam. Yeah, this integrates with POC. Yeah, it's really good, especially for those that started doing Haskell without a language server. And I don't know if I'm using it like to getting all the benefits I should, but yeah, let's search the Haskell language server. Sorry, close the chat instead of closing the. Yeah, well, I think I was using Haskell. I started to learn at the end of 2017, with the Delft study group. They did a Haskell book study group here. I was just using text editor and GHCI, not even GHCID, until I installed it like 1 or 2 months ago. No, probably a few months, like 3 months ago, I don't know. So for me it's been always just like that. Yeah, type at cursor and go to definition are already loaded. So how do you get the automatic imports? Is it a Cockbean thing or like, for example, what can I import? By the way, you should follow Sublat and Optical as well. Quick fix and okay. So am I doing? So this is functional snails. Yes, of course. I think it's this here. So I think this evaluate comes from IPsec. So yeah, I need to merge this to remove. Map for do code action online. Let's try it. Okay, where do I have? This is like the most messy MRC that you'll ever find. I have a fix. I guess the question, have you had any luck using autofix, is probably for Cblast, because I don't know if I ever use it. Oh, the list of solutions. Yes, I have a okay. Maybe I have it like that, or I have it in my work. Let's put it here. So either okay. If I do okay, I can do 2 there. Then this one, what's the other key binding? Quick fix. Here, quick fix. Okay, I think that's yeah. Oh. Nice. Okay, so that works. I need to check. I think I have it in my work machine. I have a key binding for the list of suggestions. Get back. And for now, yeah, so this does belong here. Let's move it to this. NFT data count. Parallel strategies. But I don't have big segment code. Oh, now it's broken. Nice. Is that the job you mentioned with TypeScript as well? Congrats. Will you take it? Or are you staying with Python? Nice. Congrats, man. Great. Is it like a remote thing or the data defined somewhere else? Ah, it's in parallel strategy. That's why I didn't need to import it. Okay. Nice. Well, I guess today it's super common. With celebration. Okay. And will you be doing also frontend with TypeScript? Or that's more of something they haven't? Yeah. Well, I'm personally been liking it, the remote work. So nice. Yeah, you'll not, if you have to do some pure script, you'll notice the TypeScript. I mean, you'll notice that the difference is big, mostly because overboard with this. But I think it's mostly meant, like the PTS stuff is mostly meant for people that don't know FP already. So if you know, you should be fine. But if you're learning FP with FPTS and you've been using TypeScript more like softly, let's say, like you'll have to dig deeper in TypeScript and then also on FP at the same time. So maybe it's not the best thing. Okay, so it's time to start with chapter 3, which is about parallel strategies. and sorry, evaluation strategy. So the first thing it mentions the optical. Were you reading like the online version of the book when you did it? I think so, right? It's chapter 3, which is evaluation strategy. Maybe I think I need to open the online version because this is not so handy. Whoops, I messed up the stream. I thought I was moving the window and I was moving the scene in OBS. Yeah, what I find annoying is like opening the book and going and reading. So yeah, we are in chapter 3 about evaluation strategies. Then yes, we can. That's actually O2 because the first chapter was just the introduction. So we can add 03 to be strategies. Okay. So evaluation strategies. We start talking about basically what strategy is. Why is there an error? I thought this was a was fine as the name of the file. I wanted them to be in order, but okay, there we go. So start talking about strategies, and basically strategy is strategy of A interesting. I'm not great. It needs to be successful. Okay, I need to run test yet. Did you check if there is any open issue about that? rabbit hole, okay. So what was the code action? Okay. I think I had this as leader. What's wrong with it? Easy. I don't know how to win. Okay. So this is basically a strategy. It's just a type alias for the strategy to evaluate some A. It's just type alias for a function that goes from A to the way you evaluate it. So for example, strategy to evaluate pairs could be strategy of A and B, right? Okay, and yeah, there is a type synonym there. So yeah, you can do, for example, pair strategy where you take the A and the B, then evaluate both in parallel. This is par pair. Actually, par A and then return A and B. Par, sorry. Okay, so we can have the pair that evaluates in parallel, and this is basically the. Do I have it now? Let me open again. R-par strategy that we saw. Yes, it's a monad, so you most probably can. So this will be yep, it works. Yeah, it should work. I don't see a reason for it not to work as expected. And this is basically the R-par strategy we saw already, where both things start to evaluate in parallel, but the function returns instantly. Yes. So let me explain, Pasha, that's a good question. If you're not doing Haskell, yeah. So these two things are the same, basically. These two here lets you. Well, the main difference, and like to start before of this, is that instead of doing statements, where you run different statements in like any imperative language, for example in Go, right? In Haskell, it's all about the evaluation of expressions. And then there are a lot of ways to combine those expressions depending on what they are with functions. So, and this do here is a syntax sugar for doing as like kind of like chaining expressions, right? Where you evaluate the first expression and then the next one, and then you can produce something out of it, and it's all based on these contexts. In this case it's a strategy, and it's called monads, and they basically give you this capability of doing things, doing a chain of expressions. And this is just the same translated to another syntax. And the function monad here. I think so. That's a good question. Yes, I think so. Because no. Sorry, this is not function monad. This is the eval monad. Because strategy, it's basically is to eval of A and B. Is this type alias, and we have the arguments here. So this is not the function monad. I mean, I don't know how eval is implemented, but this is the eval monad. So the do comes from the eval monad. But we can test this out. Maybe we can test it. Yeah, let's continue a bit with the content, and then we can. Actually, it's doing it now. So where was the Fibonacci ported from? We have it just here. Okay. So if we just paste our Fibonacci thing, and then we. Yeah, it's a like it requires a better explanation, a bit longer one, but that's kind of like a very short explanation. So in this case, in the shorter version, what happens is that this thing, so this is a pair, right, of A and B. And this lets you construct the pair. So if we check in the REPL, it doesn't matter. So what's the type of this thing? It's a function that takes an A, takes a B, and then gives you the pair. So basically, it constructs the data type, and what we do is that first we map the first one, so we kind of like put the A in the first element of the pair, and then we apply the B, but they are first evaluated under this function. I don't know if that makes too much sense. Okay, so what do I need to fix? I didn't move this file. 03. Okay. So what we can do now is doing our Fibonacci in parallel. Yes, we do have the pair. Why does all of these get broken? Okay, so now we have another problem where we need to hide these as well, and that should work. Yeah, this produces two integers. We can show the number. Comment out for now. Okay, put a match is with IO expected type IO type path. Is this what am I missing? This is from about A to A. Yeah, so this should give us the tuple of the two results, and that should be fine. Of these. Please with IO. IO chat. Oh my. Okay, there we go. Then main complaints now. Yes, from strategy 03. Okay, so this will take a second because it's evaluating the two of them, and I think we should actually compile, see the difference, and probably in the REPL code that's not optimized takes even longer. I don't know if the REPL code also runs with more cores, but just stack build. Okay, so took this time, and that was with 2 cores, and then we run it with 1. Why does it take longer with 2 cores? Getting Yeah, I see the new people trying. Hello chat, how are you doing? I'm just getting lost into this evaluation thing. So I remove say like we can say time. So it took 12 seconds. Yeah, not much speed over there. I don't know what's wrong with it. Okay, give me a minute. Let me take a break. I'll be back in like 2 minutes. And I'm back. Okay, let's continue with the book. I'm back, but I didn't change. Sorry, didn't change it there. Okay. Anything? Hola, Pavel. What's up? Are you ready to switch from Go to Haskell, Pasha? Am I a good inspiration or not? Okay, so the other thing that's just like defining something useful, like handy to do, is defines this using. So now instead of doing this, we can say our pair even use pair. What is all Haskell and pure script native Go? Yeah, there is a pure script, a Go backend for pure script, right? PureScript native apps in this platform. This is a platform native compiler for PureScript. Yeah, C++ and Go. How stable? Well, I see there is quite some contributions here. Nice. Yeah, this is not needed. Thank you, Linter. Okay, so there is ambiguous using. Basically, we are just defining all the things that parallel strategies already defines. For the ones that are yeah, nice. I'm easily distracted though. Wait. So this shows I added the support for some of the modes which don't show in Twitch. But what about ay? It's like that? Ay. I don't know how. Yeah, that one shows now. It wasn't showing before. Nice. Okay. You see? I get distracted even with myself. Yeah, I did enable them. Maybe I need to enable. Okay. What else? Now I'm going into the rabbit hole of distractions. Okay, so I enabled these ones, and I guess they can go now. Yeah. Important things to do. Okay. But you didn't enable them? I mean, here for sure it doesn't show in the Twitch thing. So I not only had to enable them, but also I had to do this where, for example, if we go to modes, did I add that one? Let's add Omega Lul. And I guess it's these ones that are working. So let's check another one that I don't have. So if I do tab, yeah, that one doesn't show. Okay, so you need to add them to your channel, and then that's probably how they get you to pay, because you have only 15 emotes plus other 15, which is quite a lot already. Okay, back to Haskell. So this is for those that are not familiar. Oh, sorry, Mike. Familiar to Haskell. So you can put any function between two backticks, and it becomes like a infix version of the function. So here we say that using has this as the first argument and this one as the second one for pair. But if we put it with backticks, in between backticks, then it can be evaluated. It can be used infix, and that's cool because now this reads as if it was yeah, reads more naturally. Basically, we are evaluating these using this strategy. Okay, so yeah, let's continue. And because the strategies return the same value, if we remove this, it should produce the same result. Move the parent, right? So that's kind of the idea. So then we can take this basically even further, and then we can say, okay, what if we make, because this is evaluating the two of them in parallel. Yes, it's a par pair. So let's remove this one. Let's keep this one. It's a bit more clear. So we have the two that are evaluating in parallel. So what if we want to evaluate one in sequentially? So we can do something like a val pair, where we get the strategy for A, the strategy for B, and then we produce a strategy for A. So a val pair now takes the strategy for A, the strategy for B, and the A and the B, and it does this. But instead of doing that, it uses strategy of A and the strategy of B, right? What's wrong with it? B, sorry. And so now we can update our par pair, where we do a val pair, and then we say r par, r par. So we val the pair. Sorry. Yes, yeah. We will evaluate the pair with this strategy, and this returns us basically this strategy here. So in other words, it means that we do parallel strategies. The type of R is basically an strategy on its own. A strategy to evaluate a single value instead of evaluating a tuple or something. Yeah, the other thing that we saw was yeah, so basically these are par pair in this case, evaluating always to weak head normal form, and so if we import where does deep stack come from? Control. So if we import here, we had deep sec. We took a look at this, and then type of sec. So sec evaluates to weak head normal form, and deep sec evaluates to normal form, and just takes this normal form data type class or constraint basically. So we have then those keys and rditsec. were we? Yeah, here. So let's import it. Which is basically defined as sequentially this. Yeah. Okay, what was next? Okay. Then there is the this combinator. Par width, which is basically take a strategy and returns another that will run in parallel. So we can take par pair and even further say that it takes the strategy for A, strategy for B, and returns strategy for A and B. So the strategy of A, the strategy of B, and then we do a val pair, right? Which same way we did here, but now for each strategy and we use this one. This is the latest version of our pair, and then we could, for example, to say a specific strategy. So in this case, we could use this to make it. This goes to normal form. So we'll do something like par pair, where in each case do this, and this will be and pay of A. Let's keep it undefined. Sorry. It's better. Video implementation. Keep par pair. Call it keep par pair. Yes. Then this is ambiguous. There, no fix. There. So what happens here is that we have a strategy for a pair, where each pair will be fully evaluated to normal form in parallel. And then I think from now the last thing that it was showing is this R0. You can take a look at that here. So what's the type of R0? It's a strategy, and it basically doesn't evaluate. It's just when you need a strategy but you don't want to evaluate. I think it's defined as A. Yes, the one, and it's just return that the same thing, which we could basically remove this and basically just puts this inside the parallel but doesn't evaluate. It's already defined, so we don't need to define it. Okay. So we saw this thing, basically the evaluation of now 2, 3 was it? Yeah, we saw the par map where we evaluated maps parallel. And it basically it's doing two things. It's like it's mapping and then deciding which strategy to use. So basically it book defines these. Where first we map something, and because lists are lazy, this works, and then we use the par list with rsec. But why is it using rsec, not rpar? Yeah, part list already comes from strategies and basically evaluates the list parallel list elements in parallel. Okay, so let's do an eval which is already implemented. Let's hide. That basically takes strategy of A, returns strategy of A. When the list is empty, we can ignore the strategy and we can say return the empty list. Otherwise, grab the strat, then grab the head tail of the list to what we did before. Strat for X. The rest comes from the val list. Strat and XS. Yeah, ignoring is the same thing. This is a val list. What is wrong? Nothing. And then we can just say that val list strategy of A, where the And now this is redundant, not redundant but ambiguous. Okay. This is how we basically could define the evaluation of a list in parallel. Yeah, so all of these are defined by parallel strategies. We don't need to define them, but that's kind of the exercises we are doing. Okay, so I want to review before we continue. Strings. Talking final bed. Okay, so okay, let's check our par width. How is it? Yes, it's just going par takes thread and it does par eval. Okay, that's a good question. I don't have a big project myself, but maybe someone in chat can suggest like a project to look at. It's a good project to look at. So this is, for example, the library that you're using for parallel evaluation, and this is. It's quite documented because, well, it's a public library. And these are all the strategies that we see. Deprecated code. These are all the imports. But yeah, that's a good question. I'm going to start working on a pure script project. I think I will basically be doing that and this on Thursday, that project, and on Tuesday the book. So we will go through the structure of project. Pure script is very similar to Haskell, so more reasons Pasha to join this. So, but we were at par eval. Fine. Okay, so par eval takes eval A and returns eval A. What does it? Does our par Jesus. The intermediate leaf box is necessary in order to avoid built-in rsec par eval. In particular, we want par eval r0 to be equal to r0, not par eval r0 equal at par. Okay. So this here var val var val here. This is the lift is just something that is not documented, it's just fine here in time. So the lift box, okay, so this is used, so run eval will, yeah, so R0 is kind of like the identity. So var eval should be like this. Which is just take case test, please. Okay, yes. Oh, I could just pattern match here, couldn't it? But anyways, so let's continue. Yeah, so now part list is this would be compose, right? Composition is so it could be like this one, but then it could be just also the composition. Let's leave it like this. Okay, so now we go back to the slope in the book. So let's go for a second to the examples. So Q4, what's the Q4? Okay. I think it's 1. I kept it as 3. Evaluate. Yeah. So what's the Q3? Yes. So actually the introduction of evaluate is evaluating an argument with get normal form. Force the length of the list. What of the for? Okay, so let's add 10, but we can add Sudoku 5. Sudoku 5. Just to become. Yeah. Oh. Sudoku 5. Okay, so now what we do is, let's compare. Before we run eval just takes the eval and returns A, so that's the evaluation. We did our parmap, which was evaluating each things in parallel. And now we have var list is the same that we defined here, but using the one from the library. So it evaluates the list in parallel with one strategy for each component, but each element, sorry, of the list, we are going to do it in sequential. And so this is enough because the solve function returns string to maybe, and as long as we have the maybe evaluated, we will know if it's a just, if we have the solution or not. And basically we don't have to do this evaluate here anymore. If I'm correct. No. So yeah, and it's supposed to have the same performance. I think we can run it. So doku, doku, right? That's here. Oh. Doku 3. Back field thread. Back. Yeah. So we run the Sudoku. That was too fast. You have run. What was the name of the thread scope? This is not right. It files us no, yeah, there was an exception. Okay, so it's in data. There we go. So it takes almost a second, and let's go. Yes, this is what we saw last time. Very similar, so there is a bit of less like the second for not doing anything here, but most of the time they are doing. And then yeah, there is something here, quite a lot of garbage collection. Then we could then run okay, that was the 3 from the last time. So stack in, stack field, Now let's run it with this version. Okay. It ran a bit faster, but probably need to run like several times to produce a meaningful. So now what does thread scope says? So there is a period of garbage collection, same here, but then both cores are working. Garbage collection here. Here they're just, yeah, I guess we could implement something to run this, the statistics, right? I think so. That's it. Yeah, here we did something. So if we change these two parts here too. That's a good really. Maybe I can do that now, because I have basically now the second part of the chapter it's about example and it analyzes, but maybe we can do that in the next one because I read it a few days ago already and to refresh my memory in this, and we have only 15, so yeah, I think we need to pass, yeah, we need to pass the argument back. Number 4 with 2 cores and 4. One. Yeah, this is the one that does rpar for both, so both numbers are evaluated in parallel. And then I think this is the one that does rsec, then rpar, yes. So evaluates the first one and then the second one. And so we could use that to do some statistics. Get current time, evaluate, like accumulate all of that, and then so how it would look like. Take some IO action and returns this get current time with time. What the type of the time to IO. Then we say int for the amount of times that we're going to run this. guess we do map M. Just go to, oh no. But we don't have a we don't have them. Replicate. So how does it look like? We get the get E0 is get current time, then run the action, and then one get current time, okay, so run is an IO. So, what do we perform here? Just sequence. Not replicate, repeat. Hit run, take, and then sequence. Basically that's it's found taken and repeat. Why not replicate and run? Okay, and run. But the type of replicate is okay, so replicate m. Yes. Okay, so now we have the list. Actually, we should return just the average, right? Or we could even do let's call it on the over and I don't get what the increase it. Okay, so this then we can do basic printf on that. What is the type? Okay, just to use the same. Okay, so fine with the statistics, not the I guess we could do like 20 times things. Let's see. So we find 10 times. Away more. Takes a yeah. Doing that we this is the computation. Okay, back. Run. Something. Not evaluating. Action. IO. Okay. Then these two. Hello. Here. Okay. I think it's running only once. No, it did run all. But the other ones run instant. So I'm yeah, I get it. Why? Yes. Once it's evaluated, not being evaluated again. So what should be? Probably it was running only once. I will steal them. Same thing. something about laziness that is using me here. So how do we make sure that this is evaluated every time? Test these. What? Yeah, I'm missing something. Okay. I don't think I'm circling all the time, but yeah, the other ones takes 0. So why is that? Okay, I guess that's for me to find out later, because this is time to call it a day for the stream. So yeah, thank you all for joining. I went a bit off the rails, and I think this goes slower, the book day, than I thought it would be, but yeah. Next time we'll take a look at what is it? The k-means problem is basically a problem about finding location of these clusters of points in a map, and then there is quite things to parallelize. So yeah, that's for the next time, but for today it. So again, just join the Discord and get the updates there, notifications when I go live, and the other streamers are there as well. Buenas noches, Pasha. Thank you for joining. Have a good night. What else? Check the schedule. Yeah, and see you on the next one. Well, let's do one more thing. Who there is which there are some right. I guess not someone from the FP community. So let's not write anybody. Yeah. Bye bye.